Assalamualaikum warahmatullahi wabarakatuh, and good morning class. So today we'll be learning about moments. So moments is a topic in physics 23.5.4 for combined science. So to start off with, let's look at our lesson objective for today. So you have two lesson objectives. One, able to describe moment using everyday examples. Two, able to use the formula in given situations. So in order to achieve these lesson objectives, let's look at our steps to success. So the first thing you need to do is to define what is a moment. Two, able to describe what is a turning effect by giving examples. And three, you're able to recall the formula for moment. Alright, so we have two diagrams right now on the board. Both are doors. Now, which door do you think is using moment? So moment earlier in one of the steps to success, number 2, was a turning effect of a force. So moment has to do with something turning. If you look at the first door, so let's name this door door A. Sorry. And the other one, door B. So door A is when you open and close the door, as usual. Door B is when you slide the door open and close. So in this sense, door A is the one that has a turning effect. So door A is the one that has a turning effect of moment. So from that, the definition of a moment is actually just the turning effect of a force. One common example of this, if you look up at the textbook or if you Google this topic online, they usually give the example of a spanner and a bolt. So this is your spanner, just in case, and this is your bolt. Okay, so when you use the spanner to tighten the bolt, you turn it. So this movement is a turning effect, and this is an example of a moment. In this case, the turning effect is at a clockwise direction. Because you're turning it to the right. I mean left. Because you're turning it to the left. So the turning effect of a force, you have three important factors to look at. One is the pivot. So basically this is the center of where the object will turn. Two is the force. So you need to apply a force for something to turn. So for a moment to happen, you also need to have force. And lastly is the distance. So this distance is the distance between the pivot. So you have the pivot earlier. And also the force. Okay, so this distance needs to be perpendicular. From the pivot to the force, it needs to be a perpendicular distance. So you have a 90-degree angle there. So again, we had three: pivot, the force, and the perpendicular distance. Alright, so those are the three important factors to look at when you're looking at moment. So you need to know where the pivot is, you need to know the force, and you need to know the perpendicular distance. So let's look at another example. So you have the opening and closing of a door here. So the first thing you need to look for is the pivot again. So pivot is where the turning happens, basically the center. So in this case, the door hinges is the pivot. Second was the force. So the force in this case is the person closing the door. So let me just circle where the force is. There you go. That's where the force is happening. Yes. And third is the distance. So this is the distance between the pivot and the force, and it needs to be a perpendicular distance. So in this case, that is your distance. Let's look at another example. the turning of a door handle. So the first thing you need to look at, again, is the pivot. So this is the center of where the turning point happens. So in this case, it would be here. Number 2 was the force. So when you're turning a door handle, where do you apply the force? Of course, it's on the handle. So it's somewhere here. And third is the distance between the pivot and the force. So pivot was here, force was here. So this is your distance. Perpendicular. Yes. Yes, so in this case, you have a turning effect. The moment is turning that way. So that is anti-clockwise direction. Alright, should be easy enough, right? Now that you can kind of recognize what moment is and how to, which factors to look at for moments, we'll look at the formula for moment. So moment can be made into the formula m is equal to Fd. M being the moment measured in Newton meter. Okay, so the SI unit for Newton meter is Nm, capital letter N, small letter m. Next one is the force. So F is force measured in Newton, and D is the distance measured in meter. Okay, so this distance, remember, is the distance between the pivot and the force. And it needs to be a perpendicular distance. All right. So let's look at an example. So we want to calculate the moment for the turning effect of the spanner. So the force you used on the spanner was 10 Newton. So you put F is equal to 10 Newton there. And then the distance between the pivot and the force was 0.6 meters. So you put 0.6 meters. So 10 times 0.6 is 6 Newton meter. And this is 6 Newton meter moment in a clockwise direction. Right, so the moment, the turning point, the turning effect is at a clockwise direction. So the formula for moment, if you put into a triangle, you have that. So this can be made into 3 different formulas. Moment is equal to force times distance. That was the first one. The second one, force is equal to moment over distance. And the third one, distance is equal to moment divided by force. So, now that you know the basics of moments, let's look at the diagrams below. So in order to tighten the bolt, it's actually easier to use a longer spanner than a shorter one. Do we know why? So you have to apply the moments here. So moment for the same bolt is 20 Newton meter. Okay, it's the same bolt and you're turning it the same way. So the shorter spanner, the length is 0.1 meter. The longer spanner, the length is 0.5 meter. So using the formula earlier, force is equal to moment divided by distance. So for the short spanner, the force you need to use is 200 Newton. For the longer spanner, the force you would need to use is only 40 Newtons. So in this case, the longer spanner is easier to turn because you use less force because the distance is longer. Compared to the shorter spanner, where you use more force because the distance between the pivot and the force is shorter. And that's it for today. Thank you for paying attention.